test on convergence and divergence that I need to teach you is called the integral test. Integral test isn't used a lot. It's very, very time consuming, but I have to show it to you. So what the integral test is this. It takes your power series and it just changes it to an integral. That's all it is. The only example that I've ever come across where you have to use the integral test because nothing else works looks like this. N is equal to 2 to infinity, 1 over n, natural log of n. None of the other tests that you know work. So the only way to do this is to integrate from 2 to infinity, 1 over, I'm just going to make it x, natural log of x dx. Okay, the one on the right is something that you know how to integrate. Remember, having an upper bound of infinity is a bad thing, so we do something like this. Limit as x is approaching, nope, not x, as a is approaching infinity, you're going from 2 to a, 1 over x, ln of x dx. And this is something that you've done before. I'll give you a hint. It's a u sub, and your u is ln of x, and you can take it from here. And this is the only one really that you have to use the integral test for. In years past, when I was actually able to teach my students the integral test in a classroom, they basically memorized this, and they memorized the answer. It diverges. So there's your integral test. Okay, so let's move on. We're done with tests for convergence and divergence, and now we can move on to what's called the radius of convergence. And if a power series converges, it either converges on a specific interval, which looks like this. It could have square brackets, it could have round brackets, it could have one of each. We'll get to that. It could converge everywhere. If it converges everywhere, we say it converges and it looks like this. Or it can converge nowhere, which means it diverges. Okay, so those are our three options. So let me give you an example. And in order to find the radius of convergence, you have to do the ratio test. And rumor has it, I understand that you people like the ratio test. So let's try an example. So if I ask you what is the radius of convergence, here's your power series. N is equal to 1 to infinity, x minus 3 to the n over 2 times n. Okay, what's different here now is we have an x and we have an n. We've never had that before. Okay, so I'd like you to apply the ratio test and see what you get. You're going to have limit as n is approaching infinity, and you wind up with something like x minus 3 to the n, x minus 3, I think, 2n plus 2, 2n, and an x minus 3 to the nth power. If I did that correct, that's what you're left with. Okay, knowing what you know about limits, when you cross off what you can cross off, you get this. X minus 3. Sorry about that. You get x minus 3. And since it's coming from the ratio test, and the ratio test comes from geometric series, you know that a geometric series converges when this is true. So we're going to take our answer here, and we're going to do that. Absolute value x minus 3 is less than 1. That's the same as negative 1 less than x minus 3, less than positive 1, and add 3 everywhere, and you get 2 is less than x is less than 4. Okay, what you should notice now is if in our power series it says x minus 3, that means you're centered at the number 3. Look at what my interval is. The interval goes from 2 to 4. The center of the interval is 3. That's not a coincidence. That has to happen. If that's not right, if that doesn't work out like that, you need to do the work again. Okay, so if we're centered at 3 and you're going out to 4, or you're going back to 2, your radius is equal to 1. So in this case, the radius is equal to 1. Don't worry about the endpoints right now. That's the next lesson. We're going to check to see if it converges at 2 or if it converges at 4, or both, or neither. But that's the next lesson. So right here, our radius is equal to 1. Okay, so let me give you another example. And let's see what we have here. We're going to go into the power series from 1 to infinity. You have n, you have 2x minus 5 to the nth power, and you're all over n plus 2. Again, apply the ratio test, limit as n is approaching infinity, and when you do that whole thing, you're actually left with only 2x minus 5. I'm skipping a few steps, but you're left with 2x minus 5. And this is what we do. Absolute value less than 1. Put it between -1 and +1. -1 less than 2x minus 5 less than +1. Okay, add 5 everywhere. 4 less than 2x less than 6. And one more time, divide here through by 2, and you get 2 less than x less than 3. Okay. The middle of my interval here is the number 2.5. Look over here, 2x minus 5. That's telling you that you're centered at 2.5. If you just take your parenthesis and set it equal to 0, you'll get 2.5 as an answer. So if I'm centered at 2.5 and I go out to +3, or I back up to the number 2, my radius is equal to 1/2. And that's how you find your radius of convergence.